Hello there. Here I want to take you through some tips and important things to consider when you are doing structural modeling, analysis, and design of a fuel station like this one. You can see it like this. And one of the things you have to consider is that the spans or the spacing between these columns should be at least maybe 4 meters or 5 meters, or maybe you can even lower it down to 3.5, but I will recommend 4 meters because if you have to consider these big vehicles like the SUVs, the coaches, and the big trucks, they have a width of about maybe 2.5, so that will be sufficient to allow them to park easily for the fueling and also sufficient movement of the vehicles on this petrol station. Also, it's going to allow enough space for the installation of the fuel equipments. Another thing that I want to highlight is to do with these trusses, and it is good to leave a space here, or maybe to have at least maybe 2 trusses instead of having one long truss here along the longest side of the petrol station. It's good to have maybe at least 2, because that's going to allow easier constructability of and erection of these trusses. And of course, the same thing applies here at the corners here. You have to leave a space of about 0.2 or 0.1 meters when doing the modeling, because if you don't do that and then you run your validation here, you are going to find that you're going to have an error here appearing here due to member clash. So it's important to do that, and you achieve that by offsetting these grids here. And to offset a grid is not that difficult, because all you need to do is to just come let's assume you want to offset this grid. You just pick your grid here. You can pick parallel, quick, or whichever you want. Then you just come here and press F2, and you can put your distance, maybe 0.2 for instance, and you just press enter, and you have your grid here. And for that, maybe you don't want to show the naming of the grid. You just come here and you just play around with the naming here. If you don't want to have it, but you have to make sure that you have already escaped, so just click, then you come here, say none. Right, so you have a grid like this. So that's how you do it. So also here you do the same. So you have your trusses here spanning from here to here, also another one here to here. So you're not going to have the collision of trusses here at this corner. And of course, another thing you have to consider is the modeling of these bracings here. You can see them, and for the bracings you have to make sure they are at the mid of the web, like you can see. You have to center them like that. And of course you have to put your purlins. The reason why you put these bracings, of course, is to consider to brace this roof against the uplift force of the wind. And also, here we are going to have a channel here. You get what I mean? We're going to have a channel here so that to to take care of the water flowing from this side and from this side of the roof. And for these purlins, they are going to be placed at different heights so that you can give a slope to this roof. So that's how you do it. Another key thing to consider could be maybe the height. You can consider maybe a height of about 4 meters or so, depending on also the architectural drawings that you have been provided with. And of course, when you are running the analysis, then you come here, you do make sure you have defined all your loads like this. You can see the loads, count load combinations, you can see them. The envelope is here for all the load combinations. So when you are running your analysis, make sure you are using this option for the envelope here, and you choose it. Then you just come here and click on analyze all. You're going to see how the structure is going to behave in subject to or in response to the applied loads. And you can see these ones are now the shear measure. They're important because they help you to understand the behavior of this structure as far as the transverse forces are concerned. And also you can check your moments. You can see we have more moments on the beams along the y-axis because these spans are acting like one-way slabs. And of course, we have more loads being transferred towards the beams along the y-axis and less transferred toward the beam on the x-axis. So that is also important because it helps you to know the possibility of steel section to bend when subjected to this kind of loads. And so I think that's all for this kind of structure. I hope you enjoy the video. Thank you.